I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life, the universe.
Hello, welcome to The Naked Scientist, the show where we bring you the latest breakthroughs in science, technology and medicine, with me, Katie Haylor.
and Chris Smith. This week we're getting stuck into some sizzling science. It is barbecue time, and we're going to explain the chemistry of cookery, the science of tastes and flavours, and we're also going to try and cook something you wouldn't normally think was possible on the barbie.
Plus, news of the UK government's plan to battle the nation's bulge, but will it work? Why leaves on the line really is a reasonable excuse for late trains? And what happens when cats and dogs catch coronavirus?
The Naked Scientist podcast is powered by ukfast.co.uk.
This week, there were stark warnings from Boris Johnson that the world faces a second wave of COVID cases. Germany and Spain have seen big increases in their cases. Melbourne has declared a curfew, and parts of England are now seeing new control measures being introduced. And perhaps with this in mind, the UK government unveiled plans this week to confront one of the biggest risk factors for severe coronavirus infection, and that's obesity.
The Department of Health have published a policy document setting out a strategy to tackle the growing problem. Dolly Tice is a public health researcher at the University of Cambridge. She looks at the effectiveness of policies like this, and Chris asked her what she made of the measures.
So the government have brought in a new obesity strategy, a number of recommendations, including a kind of better health public information campaign designed to kind of encourage people to lose weight. They're also expanding services locally to help with people who are already living with obesity, and then a whole range of other measures that help make the environment a healthier place for people, to make it easier to live a healthier life.
They don't hold back on their punches, because right at the top of this report, they point out, look, 63% of adults in our country are overweight. That's a pretty big number. And then even more damning, they go on to say, well, a third of children leave primary school overweight, and a fifth of those are already obese. These are kids who are not even into their teenage years yet.
Yeah, I mean, as you say, the numbers speak for themselves. Sadly, we've known about this for a long time, but it's very difficult because it's such a complex area to know what can be done. And we often hear people say there's no silver bullet, i.e. there's no one thing that will be brought in that can help tackle this issue. So it requires a kind of multi-action approach, which is exactly what this obesity strategy is clearly trying to do. We need these policies not just to be proposed, but they need to be followed up. They need to be implemented and acted upon and evaluated. You know, are they actually going to work? We can only find that out if we evaluate them.
But Dolly, when I went to school, I know for a fact that a fifth of the kids in my class were not obese. I can't actually think of a single child in my class that was. So why are we in a situation now where we have got young children going to school and they're already overweight before they've even set foot in the school gates?
Yeah, you're absolutely bang on with that. And this is something that a lot of people are trying to study. What we understand to have changed is that we do all want to still be fit and well, but it's not always easy in the world that we live in. This obesity strategy is trying to tackle the bombardment of junk food advertising. We know that companies spend much more on junk food advertising than they do on healthier advertising. And so they're looking to bring in a ban of junk food advertising before 9 p.m. on TV and online. It's also very confusing, the information available to us. You know, we're told we should be losing weight, you know, for example, by an information campaign. But at the same time, our high streets are often littered with takeaways. You know, it's not always easier to cycle, for example, than it is to drive. It is not easy in the current environment for everyone to live a healthy life. And sometimes it can be confusing trying to navigate what is a kind of healthy life versus unhealthy options.
Let's just look through some of the things that the government have earmarked that are part and parcel of their campaign. A lot of the interventions are more carrot than stick. For instance, they've got a traffic light system on foodstuffs to encourage people to make more healthy choices, labelling up food with calories. Well, that's not new. We've been doing that for a long time. adding the number of calories there are in alcohol, because people often don't appreciate that. Fair enough, that would be a new intervention. But this is very much, again, the onus is on a person to see that information, take it on board, and then act on it. Do you think that's actually going to work?
Oh, well, you've nailed it. What you're talking about is the kind of intervention differences that require an individual to use their own resources. So they need to engage, as you say, with the information. They need to want to turn it into action and do that over a long period of time. Whereas the interventions like the banning of junk food adverts, this takes away those adverts for people so that you're not having to make that choice. Actually, on the menu labelling front, this is a very interesting intervention because it's proposed in a way that it's a consumer tool, i.e. if you put information on a menu in a restaurant, then people going there will be better informed about the nutrient contents of the food. Actually, the evidence on how effective that is mixed. What we found in a study that me and a colleague published last year is that having labelling actually is associated with healthier food served. Maybe it's the restaurants that have labelling have healthier food, so they're kind of more likely to be okay with having the information on there. Or it might be that because they've introduced labelling and know what's in their food, they've then improved the healthfulness of it. So actually this kind of intervention could be seen, rather than being seen as a tool for consumers to better understand the choices that they're making, it could be seen as an information tool for the restaurants to know what's in their own food so that they can then make it healthier or provide different healthier alternatives alongside other less healthy alternatives.
So you're a bit lukewarm on some of that then. Some of it you can see a benefit, but some of it very much the onus is being pushed very much onto the consumer. What do you think then about the proposed legislation to limit things like buy one, get one free deals, where the buy one, get one free is for something that's really bad for you? Limit the ability of supermarkets to sort of force feed us bad stuff that's high in fat, high in sugar, high in salt, etc.
Yeah, so again, it comes back down to rebalancing things so that it's just easier to be healthier. And how that's done, these are all sort of possible techniques to help achieve that rebalancing so that it's just easier, so that people don't have to think too much about it, regardless of where they live, regardless of the challenges that they face on a daily basis. So these sorts of techniques we will basically have to introduce and evaluate to understand the true impact. And this is a critical part of what I'm kind of looking forward to seeing, hopefully more information about when it comes to this strategy, is it's only by introducing some of these higher level interventions that we can actually start to build the evidence on them. And actually, there are some things that we just simply can't build the evidence on until they're introduced, a bit like the soft drinks industry levy or the sugar tax, as lots of people know. It's very hard to build evidence on the effect of a tax in a particular country without introducing the tax in the first place. So I very much hope that the evaluation side of this new strategy is taken very seriously and not retrofitted at a later stage. We really need to view introducing these measures as not only tackling the obesity issue and the kind of food culture issue, but also helping build the evidence base on some of these interventions.
We'll have to wait and see whether that new initiative works, won't we? Thanks very much to Dolly Tyus.
Along with the wrong kind of snow, the station announcement about the delay to trains because of leaves on the line causes much derision and eye-rolling among disgruntled passengers, who often might think it's a made-up excuse.
The phenomenon, though, is a real one, and it can be a very real hazard when trains go sliding past platforms, and it can be very dangerous indeed if they can't stop at red signals. Steel wheels on steel rails just don't get on with leaves.
They make the rails really slippery, so if a train tries to brake, it will just slide over the rails and it can miss stations. And because of that, we have to change timetables in the autumn. And the other thing they can do is when they build up in thick layers, they can electrically insulate the train from the track. And that means that the signals don't work properly because they rely on conduction between the train and the track to tell where the trains are in the network.
Sheffield University's Michael Watson. And in research published this week, he and his colleagues think they figured out what's going on between the leaves and the rails to cause the low friction conditions.
By brewing up some sycamore leaf tea, yes, you did hear that correctly, and then one by one eliminating potential culprit chemicals, they think that tannins, which by coincidence are also in the tea that many of us enjoy drinking, are the molecules to blame.
Michael told me what they did, and firstly, how they ended up pointing the finger at tannins.
We tried to strip back the system and make it as simple as possible while still making a very low friction. So instead of using leaves with all their complicated parts, and instead of using real world contamination, we use leaf extracts. So this is essentially tea that we've made out of sycamore leaves. And we found that we could get extremely low friction with that tea. So that already rules out anything that doesn't come out in the tea. So all the things in the cell walls. And then we looked at that extract and we removed things to see which ones, when we remove them, caused the friction to increase.
Oh, I see.
And,
so you're trying to detective-like investigate the culprit by finding which ones it isn't.
Yeah, that's right. Yeah. Chemically in our setup, we have this leaf extract, which is slightly acidic, and that will dissolve the iron, which came from these test samples, but in a real railway would come from the rails. When that dissolves, the ions are floating around in the solution, and they get grabbed by these tannin molecules. And because each ion can get grabbed by multiple tannin molecules, and each tannin molecule can grab multiple ions, by the end of this, you end up with this big, loosely bonded, cross-linked network. And that's what really causes the low friction.
And this is the black kind of gooey stuff that's causing the hassle, right?
Yeah, so when these tannins grab the ion, they also leave the solution and they turn into a black precipitate solid that's floating in the solution.
Okay, so the theory is you've got leaves falling on the track. These leaves are, degrading a bit, and there's some sort of acid there that dissolves iron from the tracks, and tannins from the leaves grab onto these ions, making this low friction producing black stuff.
Yeah, that's exactly right.
Great. What's going on at a molecular level, though? Why does this black stuff have such low friction?
We think the cause of the low friction is because it's very thin. It's almost as thin as water. So it's not viscous like honey. But when you compress it on a sort of micro scale, when the surfaces are contacting, it gets compressed very hard into this hard black plastic. And that means that you don't get the viscous drag that you would get if you were in something like honey. But the surfaces can't touch each other because every time they get near to touching, it turns into this harder plastic. So you end up with a sort of best of both worlds way of reducing the friction.
How comparable is your experiment to what's actually happening?
We've shown one thing that does cause this sort of very low friction, but we can't take the results from this and say that we're definitely showing the only thing that can possibly cause low friction. You sort of have to take it with a pinch of salt, but it's the first time that anyone has linked a particular chemical to the very low friction that they get on the rails.
What are the options for actually preventing this from happening? Because I guess that's the goal, right?
Yeah, so either you can protect the rails from corrosion, which you might want to do anyway, or you can put your own chemical down that will grab the ions better than the tannins can, so that when the ions come out, they don't get grabbed by the tannins, they get grabbed by your molecule instead, and then they can't make this big complex. Something we would like to keep working on, but as the labs are all closed now, it's hard to get anywhere with it now.
I see. So we need to watch that space. But it's interesting
Yeah.
You mentioned the tracks, because I was wondering, is the iron the thing that's the problem? Would it at all be feasible to just change the track material in at-risk places?
Track materials have been around for a very long time, and people have spent years and years optimizing. So the materials we have at the moment are quite complicated materials, and swapping it to something like nickel, you'd really be taking a sort of leap into the dark, and it'd be very, very hard to justify doing.
What about the trees, though? Does it depend on the type of tree? And is felling an option? Because there's an environmental cost to that, right?
Well, so felling is something that happens anyway. It's the sort of method of last resort that Network Rail have if they need to sort out a black spot. With this research, we can talk about which trees contribute the most, so we might be able to reduce felling where it happens, with it still being there as a last resort.
And is that a case of which leaves contain the most tannins?
Yes, yeah, that should be. Well, we know that oak and sycamore are very high in tannins. They're also very common in problem areas. So that's what we use sycamore in the study, but there's also a lot of anecdotal evidence surrounding oak.
Michael Watson from the University of Sheffield, trying to help us keep the trains running on time.
Welcome to the Naked Gaming Podcast with me, Chris Barrow.
And me, Lee Milner.
Every month we look at the latest gaming news.
Animal Crossing has been updated now so that you can swim. I mean, we're all waiting for that, weren't we?
We review the biggest releases.
Go, 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 go. Right, Bottas in front of me, Verstappen. Can't believe it.
And because there's a simulator for almost anything, we play some of the strangest ones available.
Wow, already the graphics are rough. I can see myself in the reflection. The guy, my victim, is already sat down.
The Naked Gaming Podcast from The Naked Scientists. Download it now wherever you get your podcasts.
And on the way, yes, you're hearing that correctly, I'm outside in the garden and we have a barbecue dish with a difference because Tristan Welsh from Parker's Tavern in Cambridge is here to actually do a socially distanced summer barbecue. And it's not a burger we're going to put on the barbecue, you're actually going to make dessert.
Yeah, absolutely. I mean, it wasn't going to be simple and easy with me, was it? Absolutely not. We're preparing something that, to quote Monty Python, and now it's time something completely different, right?
What are you going to do?
Believe it or not, we're going to make a pineapple upside down cake cooked in the tin the pineapple slices came in on the barbecue.
There you go, Katie. That's what's coming up. Stay tuned to find out whether or not that is going to work. Now, before we get into the barbecue science, a couple of months ago, we heard about Nadia the tiger at the Bronx Zoo in the US testing positive for coronavirus. And this week, a 6-year-old female Siamese cat also made the news as the first animal to test positive for the disease here in the UK. So could our pet cats and dogs be carrying the infection? And could they pass it on to us? Well, with us is Sarah Caddy. She is a vet and also a researcher looking at this very question at the University of Cambridge. Sarah, what actually happens to a cat when they catch coronavirus? Is it very similar to a human?
Well, from studies of cats in a laboratory, it seems that the majority of cats don't actually get any signs of disease at all, even if you give them quite high doses of infection. But we don't actually know if this really reflects what happens in the real world. So we're recommending that cat owners look out for a similar sign you'd see in a human for COVID-19.
Can they actually die of the disease, or is it just generally trivial symptoms?
There's been no cases that we know of that have died from the virus at all. The reported cases have only had very mild symptoms. So the cat in question in the UK had a runny nose and possibly a little bit of difficulty breathing, but certainly nothing life-threatening.
How do you think the cat got it then? And how do cats transmit the infection? The same way we do?
The particular cat in the UK, we know the owners of this cat were diagnosed with COVID-19. So in this case, we know that it went from owner to cat. And the other cases that have been reported worldwide, we think it's a very similar situation. In terms of transmission, we expect it to be very similar methods for human to human. So droplets or aerosols or very close contact between cats or between cats and humans.
And the critical question, of course, Sarah, is if it can go from human to cat, can it come the other way?
There's no evidence that this has occurred, but as it is theoretically possible, we are recommending that any humans with COVID symptoms are employing very careful hygiene around their own cats and making sure you're washing hands and avoiding really close contact if possible.
What about other family pets? Because obviously some people are cat people, some people are dog people, some people keep birds. We've been asked about the risk of all of the above.
No, absolutely. Experimental studies have suggested that dogs don't become readily infected with the virus. But having said that, a number of dogs worldwide have been detected to have virus in their bodies. Some dogs are known to make an antibody response or an immune response to the virus, suggesting very low levels of infection, but we don't think they're as susceptible as cats.
And what about pet birds? Because someone wrote to me about their budgie. Is that at risk?
Going back to, again, the experimental infections, chickens and ducks showed no evidence of getting affected at all. And that's as far as we know about birds, actually. So I'm certainly not worried about pet budgies.
So you can tuck into your barbecued chicken with impunity. Sarah Caddy, thank you very much for joining us to fill us in. That's Sarah Caddy. She's a vet at the University of Cambridge.
Now, If you like looking at stars or other heavenly bodies in the night sky, you'll know that using your telescope in a city or other place with lots of light pollution is not a good idea. It's better to get out into the countryside, where the further you are away from streetlights and vehicle headlights, the better. Taking it to an extreme, though, you're going to have to put on your thermal underwear and hiking boots. A few husky dogs might come in useful as well.
And that's because Chinese astronomers have discovered that the best place on Earth to stargaze is in Antarctica. Yep, it's on the top of a mountain of ice, which is called Dome A, and it's 1,200 kilometres from anywhere. Astronomer Matt Bothwell has been reading the research, and he told Phil Sansom what makes this spot so special.
It's a general problem for astronomy, right? Is that we are living at the bottom of a very thick atmosphere. I mean, it's nice for human life on Earth that we don't all die, but for astronomy, it's quite difficult. It's that all the nice signals from space have to travel through hundreds of miles of air before they reach our telescopes. And air isn't perfectly transparent, right? Anyone that has seen a mirage wobbling around or seen light wobbling around above a heat source like a radiator or a fire will get the idea that light can bend and twist as it travels through air.
That's why the stars twinkle, isn't it?
Yes, exactly right. That's why stars twinkle. Astronomers call this seeing, which is a fairly obscure word. I don't know why we call it this, but yes, it's the seeing is what we call the amount that light is kind of blurred as it travels through our atmosphere. And the real trick for astronomers is to find places where the seeing is really, really good, where the atmosphere is nice and calm and still, and we can take very nice, clear pictures of space.
That's why astronomers like Hawaii, for example, right? Or big high mountains, isn't it?
Exactly. So Hawaii is famously good for this. The Atacama Desert is famously good for this. And what this new paper has found is that there's this particular site in Antarctica called Dome A, where the seeing is maybe better than anywhere else on planet Earth.
How much better?
Astronomers measure seeing in something called arc seconds. An arc second is a very, very, very tiny angle. So 1 arc second is 3,600th of a degree. And it's basically how much the light from a star or light from a galaxy has been spread out by the atmosphere. If you have seeing below 1 arc second, that's generally considered pretty good. Down here in Antarctica, in Dome A, the seeing gets as good as around 0.1 arc seconds, which is absurdly good. Much, much, much better than anything you would ever see in Hawaii or Chile.
Is this sort of like a measure of how blurry the stars are when you look at them? And so this place, if you look up at the stars, they're 10 times clearer than this gold standard.
Yeah, that's exactly right. So it's 10 times clearer to our telescopes.
Where is this site exactly?
So it's called Dome A. It's in the Antarctic. I think it's relatively close to the very slap bang center. It's essentially one of the highest points in Antarctica, about 4 kilometers above sea level.
What would this make a difference for? What kind of thing would this be useful for?
Okay, so I would caveat this with the fact that I'm a long wavelength radio astronomer. I don't really do much short wavelength, like optical astronomy type stuff. But getting better resolution in telescopes is all about being able to see objects that are close together. And so 2 binary stars, for example, might blur into one if you have bad seeing, but with this crystal clear seeing, you'll be able to separate them and see that they're actually 2 separate stars. Or exoplanets, for example. So planets orbiting other stars is one of the really hot topics in astronomy nowadays. We want very, very, very good resolution to be able to separate out systems like that.
Is it really worth carting a whole bunch of really expensive telescope materials out to this, isolated part of Antarctica? I mean, is this sort of untamed wilderness, or are there already people there, or what?
I would say it's a lot closer to untamed wilderness than almost anywhere else on Earth. Building anything down in Antarctica is going to be a very, very substantial thing to do. But I do think it's going to be worth it. For a given value of it's worth it, right? Getting a telescope to the best place in the world to observe the universe would be very, very valuable.
University of Cambridge astronomer Matt Bothwell. He wasn't involved with the original study. That was by Beijing scientist Bin Ma and colleagues, and you can read it in the journal Nature.
And if you want to find out more about any of the stories we've been covering so far in the show, all of the transcripts, as well as the papers and the references, are on our website, thenakedscientist.com.
The Naked Scientists podcast is produced in association with Spitfire. Cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Now, it's August, the sun is kind of shining, it's not raining at the moment, and we're in the holiday spirit. So what better way to celebrate than with a barbecue? Cooking and eating outside can feel and taste like a real treat, and this week we're finding out why. So stay tuned for the chemistry of flavours, the psychology of taste, and why do those pesky wasps always want to get into a slice of whatever's on my plate? Well, we'll be finding out.
Now, you did it, Katie, because you said the sun is shining. And guess what? In traditional British fashion, it's raining. It has literally gone from sunshine to rain. You would not believe it. I am, of course, here with Tristan Welsh. He's been actually knocking up this cake because we are going to cook a cake on a barbecue. If you didn't believe that it was possible, keep tuned in to see the history being made. It can be done. So just remind us, what have you put into these cakes, Tristan? How are you actually doing this?
Well, first of all, I've got to say, this is not the first time I've ever cooked a pineapple upside-down cake on a barbecue, but it certainly is the first time I've cooked in the rain. So I've taken the butter, and now what you can hear is the sugar and butter in there together. That's being creamed together, so it's a basic sort of sponge mix. To that, I add our eggs, give that a jolly good mix, then our flour, and you're using self-raising flour. Now, I've taken tinned, like individual small little tins. I think they're 250 grams, 240 grams of sliced pineapple. I've taken the top off, poured out the juice, drank it actually, put one slice of pineapple back on the base with some golden syrup and a cherry in the middle of the pineapple slice, and I'm just about to pop this cake mix on top of it.
Just the quick rundown of the ingredients in terms of what sorts of proportions, how much of each?
150 grams of unsalted butter, 150 grams of caster sugar, so it's equal quantities. To that I added 2 eggs, and now I've just added 150 grams of self-raising flour. We give that a jolly good mix, and that'll be quite a tight mixture. So then we add a couple of tablespoons of milk, and that loosens it up. In the bottom of the tin, I put in about a tablespoon of golden syrup and 1 slice of pineapple with 1 cherry in the middle.
And then you're going to spoon in fill the tin to the brim with a mixture.
Yeah, take this mix, and this mix fills about 4 tins up quite nicely.
Okay, and that then goes, we've got a barbecue with a lid. That's probably important, is it? Because we're basically using the barbecue as an oven.
It's vital. So the actual thought process behind it is the heat from below is quite aggressive. So that's going to boil the syrup, and the syrup will protect it and prevent it from burning. The lid creates the oven-like effect, so it will bake as an oven, but be able to take the aggressive heat from below.
Temperature gauge says about 200. Is that 200 C? Is that a bit hot? Okay.
That's about right. That's about right. With barbecuing, it's about using your senses and feelings. And, after 5 minutes, you can see it starting to bubble up. If it's not burning, it's okay. It's okay. But definitely around about the 200 mark is about perfect, actually.
How long do you anticipate we're going to need to put this on for?
I'd say about 15 to 20 minutes, to be honest.
We'll come back in 15 or 20 minutes. Thanks, Tristan. Also with me is biologist and champion of the world of creepy crawlies, well known to the naked scientist. That's Doctor-to-be soon, Eleanor Drinkwater. She's just a gnat's whisker, to take an insect analogy away, from handing in her PhD thesis. Welcome to the show, Eleanor. You've brought along something for the feast.
Yeah.
What is it?
Yeah, so I've brought along some edible crickets.
What?
Edible crickets, yes, in a variety of excellent flavours as well. So these guys haven't actually tried them, to my knowledge, is that right?
You're going to make me and Tristan eat insects?
Yes, you're going to discover how wonderful insects are. It's probably going to change your life.
I have to say, Katie, that actually I knew Eleanor was on form because I came out to start the show and she's already caught us a wasp and got it under a glass, buzzing around on the table. I said, are we going to barbecue that?
No. You have to watch it and admire it before letting it go very gently. That's what you have to do when you find a wasp.
I feel you're very brave for catching wasps. I am not a fan.
In the rain.
Yeah. Sadly, no barbecue for me over here in the studio. But to console me down the line is flavour chemist Jane Parker from Reading University. Jane, what do flavour chemists get up to?
Well, we do a lot of sniffing, and our job really is to identify the key aroma compounds that are in the foods and work out how they're formed and how they interact with other components in the food and how they're released and eventually how we actually perceive them. So it's the whole story, really.
Sounds delicious, and we'll come back to you very soon. Also with us is sensory scientist Barry Smith. Barry, how does your research relate to food?
Well, I'm interested in finding out what happens in us once these wonderful flavour compounds have got together in the way that Jane described. So I look at the science of tasting, and I'm looking at how our senses work together, touch, taste, smell, maybe sight, maybe sound, to give us that unique experience of the flavours of foods that we like.
And we'll be tucking into the sensory side of barbecue later on.
Right, Tristan, I suppose you've now got the tins full. So we've got greaseproof paper lining the tin. There's the piece of pineapple in the bottom with the cherry. You spoon the mixture on top. And now what are we doing?
So we're using the tin to bake the actual pineapple upside down cake. I've lined it carefully with greaseproof paper, popped it on the grill so there's intense heat coming from underneath it. And we're going to pop the lid down, let it bake essentially.
You've also got them on there alongside the sausages. You're cooking up some nice sausages. Are we not going to get sausage-flavoured upside-down cake, though?
Maybe this is a new thing. Who knows? I think we'll get some of the smoke from it. And that's really important part of the flavour and all this sort of stuff. But it's one of those sort of crazy days with pineapple upside-down cakes, sausages and cake and cooking in the rain, right?
It's already smelling really delicious. Katie, get a quick whiff of this down the mic. This is the sausages.
I'm so jealous.
Oh, it smells amazing, I'm telling you.
Jane, you're a flavour expert. Before they get to try some of this delicious food, what exactly is flavour? Are we talking smell, taste?
Well, all these words, flavour, aroma, taste, all get a little bit confused in the English language. As scientists, we've got a clear distinction between them. So taste is what you perceive on the tongue. So that's things that are sweet, sour, salty, bitter, and umami, which is the savoury taste. Aroma is what you perceive in the olfactory bulb through your nose, and these are very volatile compounds. The combination of these is what we describe as flavour, and as Barry was alluding to earlier, it's flavour is aroma and taste, but it can also be colour and texture and sound and other things as well.
But how will those pork cylinders that they've put on the barbecue, how will they translate to sausages in their brains? What's going on?
As you start cooking the sausages, you've got changes in the protein structure as it denatures and aggregates again to tenderise. And you've got colour formation. But the key thing is the flavour that's developing. And there's 4 different ways that you can develop flavour while you're cooking sausages. And one is the Maillard reaction. That's very well known, and it's the reaction that occurs between proteins or amino acids, really, and sugars as you heat things up. And that gives you these roasty, toasty and meaty aromas. Fats, they start to degrade as well, and when they degrade they release aroma compounds, and these help you work out whether it's a beef sausage or a lamb sausage or a pork sausage, because they give you that species character. These go on when you're cooking meat anywhere, but once you're putting things on the barbecue, you're starting to get caramelisation as well, so that's when the surface is really hot, and if you've marinated your pork sausage in anything sweet and sticky, you'll get even more caramelisation going on. And the final thing is the flavour that comes from the charcoal itself. The charcoal is made from wood. Wood contains lignin, and there will probably be some remnants of lignin in your charcoal. And as you burn the lignin, you generate a lot of smoky and spicy compounds, which are phenols and guacols, and you can even get vanilla as well, so you can get quite a fragrant aroma. And we've got some sunshine over here, and that's the smell that's coming in through my window as my neighbours are barbecuing. It's definitely that smoky element that gives the key barbecue element to your sausage.
It sounds delicious. I really wish I'd had some dinner before the show. I think Chris's barbecue, is it gas, Chris?
Yeah, I was just listening to what Jane was saying and thinking, oh dear, because I've subjected Tristan to cooking on gas. Is that bad? Or he's shaking his head and he's ruining the day.
It's a little bit of a faux pas, to be honest.
Oh, sorry, Tristan.
So
is that a problem, Jane?
I think you can get away with it because you've got the high temperatures, you've got the Maillard, you've got the flavour from the lipid, and you've got the interactions.
I almost went home.
It's a no from Tristan, Jane.
Oh dear, I'll leave. I'll go home too.
Rental chef. I think it works because you've got the fats hitting the flame and the flames are licking the outsides of the sausages and stuff like that. So it works. Yeah. It works, but
you get the same smoky aroma.
Smokiness. There's a little smokiness that you get from the charcoal, which is something really special.
Chris, I'm rather jealous.
Well, we'll save you some. Tristan Welch, you were just hearing there, he helps to run Cambridge's Parker's Tavern. Big weekend for them because you've literally just reopened after lockdown. You're actually creating some amazing smells in my garden. Tristan's come over for a socially distanced barbecue. I don't normally get a head chef to come and run my barbecue and then critique it. Thanks, Tristan. But we are making a cake on the barbecue. Do you want to give us an update how we're doing? It's been on, 10 minutes?
Yeah, and you can see the cake mix is bubbling up. It's rising. They look like mini soufflés almost. But the top of the paper is starting to toast a little bit with some of the mix that's stuck on the side. That's a great indicator that everything.
We're not going to eat the paper, are we?
No, but it's just an indication that things are cooking. Well, I don't know, maybe. I mean, sausage flavoured upside down cake, you never know.
No, seriously, this is amazing. They've risen right out of the top of the tins and they're beginning to look really amazing, as are my sausages. And it smells good.
Yeah, it smells great, doesn't it? I've got to say, they are bubbling away beautifully. Just going to take a few more minutes.
He's a confident man, isn't he? With us also is Barry Smith, who's a senses scientist and is joining us to tell us about some of the way in which my senses are being stimulated today. Now, Barry, people characteristically say that things do taste better when cooked and consumed out of doors. Is there any science behind that?
I think there might be. I like the idea that our senses are being bombarded while we're waiting for the food to cook. We're seeing the colour of the flame. If you had charcoal, Chris, you'd have a lovely grey-blue flame there. You're smelling the barbecue. You're hearing the sizzling. And all of these things are giving you expectations about what you're going to taste. And they're probably giving you expectations that are going to bias and make it even more pleasurable to taste the food. People are also tempted, I think, when they're eating barbecue food to eat with their fingers. And of course, that's a very natural thing to do. People say we eat first with our eyes, but we eat second with our fingers. Picking something up, you will gauge from your fingers, which are very sensitive. What's the texture of this? Is it sticky? Is it sharp? Is it crunchy? Is it soft, squidgy? And that gives you a good expectation about the texture as you put it in your mouth. So I think all of those things are being primed especially well. If you're in a kitchen, you might smell the cooking smells, but things might be in the oven unseen. You don't see the smoke and you don't want that indoors. So I think this is making a big difference.
In terms of flavours and things, Barry, you were talking about the sort of tactile nature of food and that being important. That sensation is obviously being integrated with all of the other assault on your senses that comes with eating posh, nosh and fine food. If you make the food spicy, that's not actually a taste or a flavour, is it, the spiciness? It's just a burning sensation. But does that add a dimension as well? Is that an additional stimulation that makes the food have an extra something?
Yes, it does. This is one of the hidden flavour senses, and it's employing the trigeminal system. So as you know, Chris, the trigeminal nerve is the fifth cranial nerve. It comes from behind the ear, goes to the eyes, the nose and the mouth. And it's the one that rings bells when you have too much wasabi and you feel it at the bridge of your nose. You feel that ouch sensation. And also, if you have too much irritation of the trigeminal nerve, the eyes will water because they think they're under attack. So when you're having too much spice, that trigeminal nerve makes peppermint taste cool in the mouth, mustard taste hot. And therefore, even spices like vanilla, which seem very gentle, that's a spice, these are just giving you that tingle. Ginger, obviously, garlic, all those other things, black pepper. And these are wonderful flavors to add. So you need touch, you need taste, you need smell, and trigeminal stimulation to get the flavors we love.
I've got to ask you, Barry, because, of course, in recent months, we've seen the case definition for a person with coronavirus change. It went from just have you got a cough and a fever to have you got a cough, a fever, have you lost your sense of smell and taste? So what's the implication for people who have had coronavirus and have seen their sense of smell and taste change in response to this?
This is very well known to Jane and to me, since we were part of a team with colleagues from ear, nose and throat surgeons campaigning to get the government to recognise that loss of smell and taste were symptoms. So very often people will say, I've lost my ability to taste food. Now, when that happens, I'm not sure it is taste. I think it's mainly smell. And I usually ask them to put a bit of salt on their tongue, a bit of sugar or lemon juice. Can you taste that? And if people say they can taste that, but that's virtually all they can taste, then you know what they've lost is their sense of smell. And it's really at that point that they recognised how much smell was contributing to the pleasure of eating. The fruity notes, the meaty notes, the taste of an onion, none of that comes from the tongue. That's all combining what the tongue provides with aromas in the nose. So a lot of people started to say the food was dull. Their coffee tasted of nothing. And of course, if you think of coffee without the wonderful smell of freshly brewed coffee, it's just hot water with a bitter flavour. So a lot of people noticed first in their food that they were lacking their sense of smell because of one of the symptoms of COVID-19, and probably because the nose is a major infection site for the virus.
This is dubbed parosmia, isn't it, Jane? What are you actually doing to try and understand more about what flavours people can and can't perceive? And is it true also that people are saying that when their sense of smell and taste does begin to return post-COVID, that actually it doesn't come back all at once and everything begins to taste normal all at once?
Well, what Barry was describing was anosmia, and that's when you completely lose your sense of smell. And many people with COVID will get that back after several weeks. But some of the more unfortunate people, it will linger for a bit longer. And one of the things that happens in the recovery process is the parosmia, which is when everyday smells can be distorted and are repulsive. And frankly, people, in severe cases, they can't be in the same room as people cooking, people drinking coffee. Cooking for the family becomes a problem, eating becomes a problem. It can have an impact on mental health. So we've been carrying out a study which started before COVID, because this is also happens with other viruses. So it's known before, this parosmia phase. So we've been looking at what foods in particular trigger this parosmia, because it's only certain foods, and then what chemicals, what aroma compounds in particular. And I have to say that a barbecue must be a parosmic's nightmare, because the things that we're finding that are triggering parosmia, coffee is one of them, and coffee is the most common. But after that, it's meat and chicken and beef, and it's the cooking process which is often described as the worst. It's onions, it's peppers, it's cucumbers, so even the salad, it's not just the cooking process, it's a series of really potent aroma compounds which are the triggers.
What could a person who's suffering with this expect then, and what can they eat?
Although we've got a group of things that parosmics tend to hate, the things that they like is a lot more variable, but it's generally bland things. It's pasta. There's a lot of fruit and veg that is okay for many parosmics, but it's not without exception. Watermelon is horrible for some people, and that's really quite bland.
If you're someone who's unlucky enough to find themselves in that position, what's going to happen to you? Is this going to be the rest of your life, or will it go away?
Well, the good news is that for many, many people, it will improve over time. One of the things that is recommended by ENT specialists is to carry out what's known as smell training, where you sit in a quiet room twice a day and you've got a range of essential oils, and you may smell nothing to begin with, but just that act of smelling the essential oil and thinking about it and going through that process helps you mentally, and it also helps, we believe, to stimulate regrowth of the neurons which have been destroyed as a result of COVID.
Which sounds promising. So do you have any feeling yet for what proportion of people are going to improve, what proportion will probably stay the same, and what proportion may even get worse?
I think it's unlikely that anybody will get worse. We just don't know, because we haven't had enough people going through. The parosmia stage happens, so there's a 3-month delay, so we're only just now getting the influx of parosmia people. So we don't know enough about how many people will recover. I know that from other non-COVID parosmics, there are some who don't recover. Even 8-10 years down the line, there will be one or two, so we can't promise that everybody will recover, but most people do. But it does take years. You'll make a slow change from your foods are really repulsive and horrible. Things will start to get slightly better. They'll never return exactly to normal, but you'll learn to live with them. You'll learn to recognise coffee as what it is now, and rather than hate it. But it does get there.
Well, thank you very much for the reassurance and for bringing us up to speed on it, Jane. Tristan, the moment of truth has arrived. We have to lift the lid on the barbecue. These look really good.
Yeah, and you see they're bubbled up beautifully. They're perfectly cooked. You can see they're crisp on the outside, slightly golden on the top. And if you look on the edges there, they've got that beautiful sort of golden brown colour.
The man was right, and his upside down cakes have cooked in their tins on the barbecue. We're just pulling them off now. The sausages look pretty good too, Tristan. I hand it to you. You're pretty cook a mean sausage on the barbecue, even if it is gas.
Well, who knows? Maybe I'll make a career out of it. I don't know. I don't know.
Barry, my mouth is watering in the studio. It sounds really good. But what about sound and sight when it comes to food? Because we've dwelled on smell and taste and touch, as you said. What about what food sounds like or looks like?
All of these things make a difference. I mean, if you think of the colour of food, if the colour is wrong, you don't want to eat it. There was a lovely experiment done by Wheatley in the 1970s where he had people in an ultraviolet room eating steak, peas and chips and asked to say whether the steak was tender, how were the chips, how were the peas. They were discussing the food. And then he flipped the real lighting on and you saw the steak was blue, bright blue, the chips were green and the peas were red. And some people had involuntary retching. Now that's funny because they'd already been discussing and talking about the food. So it shows you that how food looks will have a big impact on whether it's acceptable. And then of course, sound. Interesting when we're thinking of chefs like Tristan, you're thinking of them using sound to assess their cooking. Does the pan sound too angry? Is the sizzling too high? Do I turn it down? But also on aircraft, the sound of white noise in our ears, 89 decibels or above, has an impact on the brain's ability to process information from the tongue. So salt, sweet and sour reduced considerably, maybe 10 to 15%. So if you want a better experience when you're eating on an aircraft, take your noise-cancelling headphones or eat something with umami, because umami seems to be immune to this effect. And what's got lots of umami on an airplane? Tomato juice, because tomatoes are rich in umami. So that's why people have Bloody Marys on a plane and at no other time.
What about just the beautiful outdoors? I mean, Chris and Tristan and Eleanor are outdoors. What about being able to see trees and smell grass and things like that?
Yeah, I think you're getting all of those wonderful sights and sounds. Remember, some of our happiest memories, especially from childhood, if we had a happy childhood, or being outdoors in summer, having picnics, those are happy occasions. So the smell of freshly cut grass, the smell of all that chlorophyll, these are odours which remind us of happy occasions. And when you also think of eating outside, you're in a very natural setting. And in fact, perhaps we're even reminded of some of our evolutionary ancestors. It was when they were sitting around fires cooking food for the first time that they were extending their daylight hours by light from the fire. They were safe from predators. They developed jaws that were not so strong because they didn't have to have enormous bite strength to eat raw meat. They were getting these new cooked flavors. So I think there's something almost ancestrally wonderful about watching meat color and brown and give off roasted aromas. And then we're going to get the flavors we expect and see the smoke passing before our eyes. All of that is part of the experience of eating outdoors and having a barbecue.
Right, I'm definitely having my dinner outside this evening. Chris, I think the moment's come, hasn't it?
Yeah, well, Tristan's got one of the cakes out. It's on a plate in front of us. Do you want to do the honours, Tristan? You're going to cut us a slice?
Yeah, absolutely. Here we are. So I've just decanted the cake out onto a plate. I've pulled the paper away. I'm just going to cut it in half now.
It just looks amazing. Oh, seen from this, just cut it in half. And the pineapple on the top, the cherry turned beautifully gooey in the middle. Nice wasp buzzing around for you, Eleanor.
Yeah, I was just trying to catch it, actually.
The rain has stopped, which is amazing. Just you can work wonders, Tristan.
You catch it, I'll cook it.
Right, are we going to go for it? Have a fork
have
each.
it.
Eleanor, have a...
Oh my goodness, this looks incredible.
I'm just going to use my fingers, you know.
I'm going to try and get a bit that's got some cherry and some pineapple.
Oh my goodness.
Oh, this is amazing.
Wow,
Katie, you don't know what
so
you're missing.
You haven't your cake before you've had your sausages, eh?
Yeah, I haven't had the sausages yet. I'll have one of them in a minute. Jane, you're missing out big time. Sorry that you can't have any of this delicious cake.
I know.
But the pineapple on the top, on the bottom rather, but on the top when Tristan turned them out, is this beautiful texture and the most amazing array of flavours that doesn't taste like pineapple does when it's just raw in a tin. Why has that happened?
It's a very clever idea making a pineapple upside down pudding on the barbecue, because that aggressive heat you were talking about earlier really heats and caramelizes that syrup that's on the bottom. And then the pineapple, which has, when it's fresh, it has lots of esters and some sulfur compounds that make it a bit tropical. But once you start heating it, it caramelizes as well because it's high in sugar. And you get a compound that's called furaniol, which has got a really candy floss, toffee type aroma. And that really gives your pineapple that gorgeous caramel toasty aroma, that's because it's been in contact with that high heat on the bottom.
Thanks for summarising it for us. I'm not sure if I'm going to enjoy the next course, though. That's coming up in a second. But to tell us, first of all, why our flying friends have arrived. And as I said earlier, I knew Eleanor was in the building, or in the garden rather, because I came outside where we're preparing to do our socially distanced barbecue. There was already a wasp buzzing around under a glass. So not only did you find one and catch one, and that's our specimen. Why have you put it under a glass?
Oh, so we have here an absolutely beautiful common or German wasp. They're the gorgeous yellow ones that you see, and they are social creatures, and so they've actually been found to recruit their sisters, their nestmates. The best way to deal with one, if you have it at a picnic, is to get a glass and very gently put it under the glass to stop her from recruiting. If you kill her, which obviously no one should do, they release a pheromone from their head, which would attract more. And if you leave her, then she will go and attract more. So really, if you put them under a glass and then very gently release them afterwards, that's probably the best way to deal with it.
That wasp then can tell its nestmates where the good dinner is to be had, and it will go and get all its mates, which is why you've sequestered it there.
Yes, exactly. So
Do ants do the same thing?
Oh my goodness, yes they do. So they are just gorgeous creatures, and what they do is you'll have a scout who will go and find a food source and go back to her nest, and as she does, she will leave a pheromone trail, so almost like Hansel and Gretel leaving breadcrumbs. But the amazing thing then is, as it recruits more ants to the source, they also lay the trail, so you get this amazing feedback loop. As more and more ants find the food source, you get a stronger and stronger signal, so as a result you get much greater attraction to the area.
I like the way you use the word feedback, because that's sort of really what it is.
Exactly, it is exactly that. They have short-term pheromones, so that one will disintegrate very, very quickly once there's no longer food there, but they have a long-term one as well, so the ants will stop being recruited, but then occasionally go and check back, which is an amazing adaptation.
One of the reasons that you said you'd join our barbecue, because we're eating barbecue food and etc. and talking about the science of it, is you said you're going to bring us some barbecued insects.
Yes, I have them right here. So I have salted toffee crunch roasted crickets, salt and vinegar roasted crickets, and smoky barbecue roasted crickets.
You game, Tristan?
Well, I didn't think crickets was that. But of course, absolutely, I'm completely up for it. I've never tasted bugs before, other than snails.
Which flavour?
Salt and vinegar, please.
There we go.
That's my poison.
Go on then, I'll have the barbecue one since we're doing barbecue.
Yeah, it seems quite fitting.
So they're in a nice little packet.
Oh my goodness, look at that.
Yeah.
Okay, so I'm just opening the packet.
It's like a load of bugs have got into your crisps.
Yeah.
How do they make them crispy? Do they oven roast them or fry them? Or?
Yeah, how do they make them? And why are we eating insects?
So, sorry, I've got a mouthful of bug.
Quite nice, actually.
Yeah,
Another one.
They are really good. So entomophagy, or eating insects, is absolutely brilliant for the environment. So they're very good for you. They're very high in protein, very low in kind of fats and that kind of thing. But then on top of that, they are very good because you hardly need any water to produce invertebrates. They're very, very effective, efficient, turning food and water into protein. So they're great for the environment. So everyone should think about trying them.
It has been catching on, though, hasn't it? Because you can rear insects on the kinds of foods that actually wouldn't make it onto the supermarket shelves. So they can turn what would be trash into sort of nutritional treasure in some respects.
Yeah, definitely. And you have to remember that they're eaten all over the world. It's a very common thing to eat invertebrates. We're just very odd in the UK to not have entered into that. So actually, we kind of keep catching up with the times.
Serve these in your restaurant, Tristan?
Not just yet, no. Could you imagine the crickets running around the kitchen? That would be hilarious, wouldn't it? Oh, God, we'd probably get shut down. I don't know. These are roasted, and they taste quite nice. They're crispy. Do you know, I think I'm coming around to it. It's not terribly bad, is it?
You mean it's fabulous, not terribly bad. It's fabulous.
They are actually very pleasant. I'm very impressed. And Eleanor, thank you for introducing me to them. I would not eschew a cricket in the future. Well, unfortunately, we're going to have to fire down the barbecue now because we've run out of time. We better get started on the washing up. Thanks to all our guests who joined us this week. Jane Parker, Tristan Welch, Eleanor Drinkwater and Barry Smith.
Do tune in next week when we meet the COVID patients that are still sick months and months after their first cough or fever. What's going on in the phenomenon they're calling long COVID? Well, we'll be investigating. The Naked Scientists comes to you from Cambridge University's Institute of Continuing Education and is supported by Rolls-Royce. I'm Katie Haylor. Thanks for listening. Until next time, goodbye.